Welcome to Topic 1, Arithmetic and Geometric Sequences and Series. This is your review. You guys have a test coming up. Number 1, this is not a question. This is for information only. Each summer, the members of the drama club at Amanda's school do various odd jobs around the school and contribute their earnings to the drama club's treasury. This year, their school's principal has offered to pay them to help him organize the book room. The principal gives the students 2 different salary options. Okay. Number 2. Under the first option, the principal will give the students $3 at the end of the first day of work. At the end of each additional 8-hour day they work, the principal will pay the students $2 more than their previous day's salary. Under the second option, there's your first, there's your second, the principal will give the students 5 cents at the end of the first day of work. He will then pay them double their previous day's salary at the end of each additional 8-hour day they work. So, begin your investigation of each option by filling in the salaries for the first 3 days under each option. Okay? All right. You guys did this on the computer. Remember? All right. Day 1, option 1. He pays them $3. On the second day, how much is he going to pay them? $5. Okay? Because it's 2 more, right? See how the 2 more? On the third day, how much is he going to pay them? $7. Very good. All right. In option 2, he's going to pay them 5 cents. Did you guys see that? On day 2, how much is he going to pay them? 10 cents. Because he's doubling. Okay? And on the third day, how much is he going to pay them? 20 cents. All right. Did you guys see that? Very good. Okay, so right off the bat, this one is a D. What is that D equal to for the first option? 2. I'm going up by 2. Okay, option 2, I'm doubling. So is that a common difference or is that a ratio? Ratio. And what is that ratio? 2. Keep that in mind. You guys good? All right. Number 3. Remember that the salary under option 1 is $3 on the first day, and the salary on each day after that is 2 more than the previous day's salary. Under option 2, the salary is 5 cents on the first day, and the salary on each, let's go back to the next page, day, here we go, after that is double the previous day's salary. Okay? What is true about each option? Check all that applied. So let me read it through, and then you guys think about it. Under option 1, the sequence of salary starts from 3, 5, 7, 9. Is geometric with common ratio of 2. Is that correct? No. What should it be? It's not geometric. It is arithmetic. Very good. So that one is not true. And it's not a common ratio. It is actually what? A common difference. Very good. Good job. Okay? It's a common difference. It's not geometric. So, do we put a check mark on that one? No. Okay. Option number 2. The sequence of salaries, 5 cents, 10 cents, 20 cents, 40 cents, is arithmetic with a common difference of 2. Is that true? No. What should it be? Geometric. Okay. Do you have a common difference or do you have a common ratio? Common ratio. Very good. So do we put a check mark on that one? No. Good job, guys. You're doing so good. Okay? Next one. Under option 1, The sequence of salaries, 3, 5, 7, 9, is arithmetic with a common difference of 2. Is that true? Okay, so we put a check mark. Okay? Under option 2, the sequence of salaries, 5 cents, 10 cents, 20 cents, 40 cents, is geometric with common ratio of 2. Good job. Okay? You guys doing good. Neither sequence of salaries is arithmetic or geometric. No, because one of them is arithmetic and the other one is geometric. Did you guys see that? Very good. Let's go to number 4. All right. The salary under option 1 is $3 on the first day, and the salary on each day after that is $2 more than the previous day's salary. Under option 2, the salary is 5 cents on the first day, and the salary on each day after that is double the previous day's salary. Okay? Fill in the blanks using the option boxes to find a rule for T sub n. Now, we also, instead of T sub n, did we use X sub n? Did we also use A sub n? Do they all mean the same thing? Very good. The term that describes the salary the students would earn on the nth day. Nth day is any day, right? Under each option. All right, option 1. So I have my T sub n, so what goes right here? Which one of these goes right here? Which one do I put first? What? 3. Okay. What goes next? Plus. What goes after that? 2. Very good. Do you guys see how we just grabbed that? We got that one, and that one. Okay? Good job. All right. Option 2. What do I fill in next? Option 2. 0.05. Good. Okay, what goes next? Oh, not plus. Sorry. Should be a dot. I got the wrong one. Times. My fault. Okay, what goes next? 2. Raise 2. You raise 2 to the power of, okay? N minus 1. Yeah. The way you can say this is raise 2, or you can say to the power of, because I'm putting it up high. You guys see that? You can say power of or raise 2, okay? So that's how you say it in English. All right. You guys are good so far? Okay. Number 5. The drama club president says that option 1 will always pay more each day than option 2. Is his statement true or false? What do you guys think? You think it's true? I think so too, because eventually it's going to even out though, right? Okay, but for right now it's true, okay? But that's not always true, because if I do so many days, you think you might get more when you're doubling all the time? Think about it. You probably are going to, okay? So maybe after 30 days, because you're doubling all the time, you might get more. All right. So that one is a tricky question. Number 6. Which of the following describes geometric sequences? Check all that apply. Is that one geometric? Yes or no? This is arithmetic. Very good. Why? Because I'm going up by how many every time? 3. See how your D's are 3. Okay? Next one. What is happening here? Is that multiplying or dividing? Or adding or subtracting? What is this 3 doing right here? Multiplying. Is that geometric? Yes. Okay? Because you are multiplying. See that right there? You're multiplying. All right. Next one. Is that geometric or arithmetic? Geometric. And if it's geometric, what is your R? 2. Very good. I'm doubling every time, so put a check mark there. Okay? Next one, look right here. Is that one geometric or arithmetic? Arithmetic, because I'm adding. Okay, because you are adding. All right. Next one. How about this one right here? What is happening here? I'm dividing, but isn't division and multiplication inverses of each other? So is that geometric or arithmetic? Geometric. Because you are technically multiplying a fraction. Okay? Any questions so far? You guys are doing good. Okay? This will be on your test. Very simple. All right, let's go to the next page. Page 3. Good job, guys. All right. Use the figure to answer questions 7 through 8, or 7 to 8. You can do it like that. Row 3 has how many? Row 3 has how many? Let's start with row 1. What's row 1? 1. Row 2? Row 3? Are you seeing a pattern? All right. Okay. A stela formed this figure by placing a single 10 millimeters by 10 millimeter square tile on a grid and then repeatedly adding rows of tiles of the same size to the existing figure. Use the word number bank to complete the following statement below. All right, so we're going to use this to answer this. If a stela continues to follow the same pattern of adding tiles, then the number of tiles in each successive, you guys know what successive mean? Okay, this one after the other. Successive row of the figure will form what kind of sequences? Arithmetic, okay? And arithmetic. Because you guys saw how you were going up by 2, right? Okay? An arithmetic sequence with a common what? If it's arithmetic, difference. Very good. Okay. Of what? Of 2. Awesome. The total area in millimeter square, or square millimeters, of the tiles in each successive row of the figure will form what? Now, you're squaring it. If it's squaring, I'm doing a number times another number every time. So what would that be? Geometric. See that square right there? That's like, a square means like 2 times 2, 3 times 3, 4 times 4, okay? A geometric sequence with a common what? Ratio of, let's see. We're going to try something real quick, okay? Before we answer this question, let's go back up here. All right. Each one of these is a 10 by 10, okay? You see that right there? What is 10 times 10? 100, all right? So what would be this one? This is 100 plus 100 plus 100. What would that be? 300, okay? 100 plus 100 plus 100 plus 100 plus 100. What do you see? 500. And it keeps going, right? Do you guys see a pattern taking place? What is that pattern? Now, is that still going to be geometric? No, so what is it going to be? Arithmetic. I'll be adding up. With a sequence with a common what? Difference. Very good. Okay. Of what? 200. All right. So if you ever get stuck, go back and do what we just did up here. Do you guys see that? Because the square is 10 times 10, which is 100. Okay? So far, so good? All right. Here, I'm going to leave that on for just a little bit. Okay. Number 8. Are we ready? Are we ready? Okay. If Estella continues to follow the same pattern of adding tiles, she will need how many for the 100th road?
199.
Alrighty. Now, you might want to do a formula to help you. You guys ready? I don't know. Okay. A sub n, here's your formula, plus dn minus 1. Is that your formula? All right. What is our row right here? 100, correct? So I'm going to say a sub 100 equals your first. What is your first term right there? What's your first? What's your first on the row? 1 plus, what's your d? 2, and what do I put for my n right here? 100 minus 1. What answer did you get when you do that? 199? 99 times 2 is 190. It is 199. Okay. 199. All right. You guys good? Okay. Now, you can type this into your calculator if you don't know. Watch what I do. Okay. 1 plus 2, parentheses, 100 minus 1. And that's how Andres got 199. You guys see that? He just typed it in. All right, let's go to number 9. A ball is dropped from a height of 160 centimeters. Okay? The ball loses 25% of its previous height after each bounce. Fill in the table with the height after each bounce. Alrighty? So, he starts off with 160. Alright? He's losing 25, so how much does he actually gain? 120? So you go times 0.75. Okay, so it'd be 120. Do you guys see why multiplying it times 0.75? Because a percent is always 100. So it is 25 from 100, 75. So you got a ball right here at 160. It bounces. So right here is at 120. What is it right here? Okay, times 0.75, 90. Yeah, because that's your ratio. How high is that ball? Start off with 160. Then it goes to 120, then it goes to 90. Do you see how you're seeing the height of that ball? Times 0.75, so that's 67.5. Okay, times 0.75, so that is 50.625. All right. But do you see how you're seeing the height of that ball? Times 0.75 times 0.75. Because 100 minus 25 is 75. Make sense? All right. Everyone good? I'm going to wait just a little. You guys understand why I'm getting 160, 120, and 90 from? Okay? A percent is always 1 or 100%. Good? You guys good? Okay, let's go next page. Here we go. Okay, number 10. Let's look at number 10. A ball is dropped from a height of 160 centimeters. The ball loses 25% of its previous height after each bounce. The graph models the height of the ball. Okay? Did you guys see the height? 160, 120, 90. Do you see how it's got that curve? What is this function called that has this curve right here? Not linear. What is it? It's not linear, it's exponential. Remember your exponential? This is an exponential. Linear would be a straight line. See how that's a straight line? That would be linear. Linear can also go this way, but see how it's a straight line? That's what makes it linear. Look at the word. What's in the word linear? Line. Okay? Line. All right. What kind of sequence is formed by the height of the ball after each bounce? Is it arithmetic? No. Okay, is it geometric? Yes. Does it have a common ratio of 0.75? Yes. Did you multiply 0.75 every time? Is it geometric with a common ratio of 0.25? Neither arithmetic or geometric. So what's your best answer? B.